Hello, ladies and gentlemen. Welcome to another lesson. Today we're going to be looking at 2.5 exponential functions. Just to get a look at the schedule and see what we're looking like. We are at 2.5, which is in our third week of class. So after this lesson, there will be one more, and then we will have our first quiz. More to come regarding the quizzes, but let's get started. So looking at homework 2.5 exponential functions, let's take a quick preview. And we can see that we have 24 questions. Clicking on the first one and going to the textbook, I'm again looking for formulas, definitions, anything really in blue that's going to stand out. I don't need step-by-step process. So let's see. This section introduces an important class of functions called the exponential function. These functions are used extensively in modeling and solving a wide variety of real-world problems, including growth of money at compound interest, growth of populations, radioactive decay, learning associated with mastery, whatever, computing. Okay, so here's an example of an exponential function. So first notice that you have 2 to the x versus g to the x. So an exponential function is when a number is raised to a power, not when a power, or yeah. So they're not the same function. So the g of x is a quadratic function because it's a variable raised to the second power, whereas exponentials, you're taking a number and raising it to a different power. So f of x is equal to b to the x, where b is greater than 0, and it cannot be equal to 1, because if it was just 1, it would be itself. That is your exponential function. The b is called the base. The domain of this is all real numbers, and the range of it is all positive numbers. Okay, just plug it in, plug it in. Let's go to the next page. All right, so here, the basic properties of the graph f of x is e to the b to the x. So if we look at 2, here are 2 to the x versus 2 to the negative x. So blue is positive x, red is negative x. Basic properties are always going to go to the point 0, 1. They're always going to have the continuous curve with no holes or jumps. They're all going to have an x-axis as a horizontal asymptote, and if b is greater than 1, it's going to be getting bigger. If b is less than 1, it's going to be decreasing. So it's less than if it's, yeah, cool. Between 0 and 1? Wait, if b is between 0, oh, we're talking about the base. I'm sorry, we're talking about the bases. Yep. Cool. Recall the graph, rational, so it's characteristics. All right, properties of exponential functions, a to the x. So here we have a few laws that we must know when working with exponential functions. If a and b are positive and a is not 1 or b is not 1, and they're real numbers, then a to the x times a to the y means a to the x plus y. You add the exponents. If bases are being multiplied, you add the exponents. If it is a base to a power, I'm going to go to division. If they are being divided, you subtract. If it's a base to a power raised to a power, you then multiply the powers. And if it is a base to a power, you would distribute the powers to each of them. Same thing goes for division. If they're being divided raised to a power, each power gets distributed. Another one is if a to the x is equal to b to the y, if and only if x is equal to y. So we're going to use this to solve it, which as you can see right here, they kind of solved it. And as long as x is not equal to 0 and a to the x equals b to the x, if and only if a equals b. So same thing. Cool. Just a bunch of exponential functions with base e or base 1 over e. So e comes up very, what did they say on the previous page? E comes up very commonly when it comes down to like, yeah, this is just whatever. It's just used a lot in business. So when we use it, it's just going to be a lot simpler. So the definition of the exponential function, e to the x or e to the negative x, it's an exponential function, so it should have the same characteristics. It's used a lot in growth and decay. There's our formula, so it's just used a lot. Exponential decay, no problem. Exponential regression, that's just in the calculator. We're just going to hit a different simple drop-down menu. Compound interest gives us a formula, and in our formula, here's our compound interest formula. A is the amount, your future value is the principal, times 1 plus the rate in terms of a decimal, divided by the m, the number of times it's compounded per year, raised to the m times t, the number of years. And then you just plug it into the formula, you kind of solve it out. Pretty straightforward. So here's a little summary. Compound interest is that formula. Continuous compound interest is A equals PERT. P is principal, R is rate, T is time, and so forth. There we go. All right, I'm done with the textbook. Let's get to the questions. So here, match each equation with the graph with this. Oh, this is really small. I can't see that. What if I blow it up and make it bigger? Huh? Zoom in again. One more time. Okay. So two of these are clearly going to be fractional exponents, and two of these are going to be clearly positive. So looking at this, 6 to the x versus 10 to the x, I mean, I really can't see, but one of them should grow a lot quicker, which is the purple line. I think purple line is f, which means this should be h. I don't see F, G, H, K, so 6 should be H, the smaller one. 0.6 should be the smaller one between the two, going negative K. This is either right or wrong. Yep, no, it's right. 10 to the X is going to be the one that moves really fast. That should be F. And then the last one is going to be G. Yep, there we go. Okay. Graph the following function over the indicated interval. So here, I see that we have 5 raised to the x. So that's going to be an exponential function, 5 raised to the x. It should go through the point 0, 5. So if I compare this one, that's 0, 0. I'm sorry, 1, 5. And this one right here looks like it goes through 1, 5. So I'm going to go with answer D. And that's correct. All right, 1 to the third x should be coming down. It should be going through the point -1, 3. That looks like this one. -1, I'm going to guess that's going to be -1, 3. No. So then it has to be this one. What point did I not go? Oh, I missed it. What point did I not go through? Between these two, it's obviously this one. Okay, whatever. Let's see. -6e to the negative x. Let's just go like this. Y equals -6e raised to the negative x, I think it was. That kind of looks like this one. Did it -6e to the negative x? I think I took it. Yep. Cool. So just a bunch. All right, so now here, based off of our reasoning, what would happen here? If I have x minus 5, what happened? That's -5 attached to the x. That's going to be a left-right movement. And because it's lying to us, this graph shifted right 5 units. Shifted right. The graph of G is the graph of f shifted 5 units to the right. Cool. What would this one do? E to the x. Well, this is not attached to x, so that should just be moving it down. So it shifted 7 units down. Cool. All right. So this graph looks like it is clearly exponential. Oh, I'm sorry. I didn't even understand what this question is asking. This is f of x, so if I make this a little bit bigger, there's f of x. They want me to now first apply this rule. Well, if it's -3, the entire graph should be shifted down 3 units, which is going to be 3. If I look at B, it's going to be shifted 1 unit to the left. Shifted C is going to be down 2, but also much quicker. And D is going to be reflected and moved up 1 unit. So if we look at B, B should be 1 unit to the left. So if I take that graph and move it 1 unit to the left, I think it's going to be something like that. If I move it, what's C? Move it 2 units down. If I move it 2 units down, something along. No, I think it grows quicker. But it's not 2 units down. 2 units down and grows quicker. Looks like this. There you go. So these were both moved down 2 units. This just one did not change the growth. And last but not least, this one is going to be upside down, up 1 unit, and shifted right 3. Shifted, I think C. No, then it has to be A. There you go. It's just hard to see all the... Okay. All right, what is this one? This one has been e to the x. This is shifted left 1 unit and then brought down 5. Brought down 5. Let's blow that up. So if you see it's shifted, here's the x-axis. It's been brought 2, 4, 6, 8, 5 units down. All right, and again, you could just put all this. I'm actually going to graph this one: e to the absolute value of x. So y equals e raised to the, and then just do abs, absolute value. It didn't accept it. How do I do absolute value? Add that expression. If I do a line, x, is that going to work? Oh, it's that kind of parabola looking thing, which looks like I mean, what happens if I plug in 4? 2 to the 4 is 2, 4, 8, 16. So it should be at 16. That's way too high. I'm thinking it's that one. No, it's the... Is it this one? I don't know what the difference is. What's the difference? The values? I think it's just the values, right? So if I plug in 4, what is this? 10, 20, 30, 40, 60. 1, 2, 3, 4, 5, 6, 7. It's not even, that scale's not even by the ones. 10, 20, 30, 40, 50, 60, 70, 80. Yeah, no. I don't know. I really don't. I don't know what is the difference between these two. Terrible, terrible scales. Okay. Moving on. Number 10. Okay, so here, what value of a squared equals a to the negative 2? I mean, there's a way to do this algebraically. What we need to do, I'm going to look, oh, it doesn't give you any examples. Okay, so if you have a to the negative 2, that becomes 1 over a, which means that you're saying that a squared is the same exact thing as 1 over a squared. And the only way for that to work out, how do I show this? Desmos. So if I were to have a squared is equal to 1 over a squared, if you put this one over 1 and then you cross multiply, you'll see that the only way for this to be true is a has to be 1. So the only way for that to work out is if a is 1. Okay. So let's try that. Y equals x squared and y equals negative x. Oh, they want me to put a comma. No. This is x to the negative 2. Right? So it's 2 answers. It's 1 and negative 1, which means that I should have had to put a comma between 1 and negative 1. Hit it, and it's that simple. Cool. Explain why this does not violate the exponential function property. Why does this not violate the exponential function? The conditions of the exponential function property state that a must be a positive and a cannot be equal to 1. No. The conditions of the exponential function state that the exponents must be positive, since one of the exponents is negative 2. Nope. The condition state that must be, a cannot be since both values. Nope. Conditions. Yep. They must be real numbers. No, then it's a. C, what does C say? C, the conditions of the exponential function state that a must be positive and a cannot be equal to 1. Since both values of a violate this condition, the property is not violated. Sure, I have absolutely no idea what this is saying. 1 comma negative 1. That's easy. And then the property is not violate since must be real numbers. Since both values of a violate this condition, the property, okay. Okay, so for here, what I'm going to do is I'm going to say 1 minus 4x is equal to 3x minus 9. Because since the bases are equal, the exponents are equal. So let me just bring this over here, and now I can just kind of do this, and I could do this, and I could say that 1 minus 4x, and I can set this equal to 3x minus 9. Find the intersection rather quickly. It's a fraction. It's a fraction. It is, set this equal to each other. It's 10 over 7. X equals 10 over 7. 10 over 7. Okay. Here you have 3 to that is equal to that. So that means that we're going to have x squared. Where'd decimal go? We're going to have x squared plus 5x plus 6 equals 0. And then negative 3 and negative 2. Negative 3 comma negative 2. Cool. Okay, let's see this one. Solve the given equation. X e to the negative x minus 3 e to the negative x equals 0. So the first thing I'm going to do is I'm going to add, hold on. Remember that e to the negative x cannot be equal to 0 for all values of x. This is getting, let me see what this looks like. I'm probably going to be solving for like decimal numbers. Raised to the negative x, and then minus 3 e raised to the negative x. And when does this equal 0? It equals 0 at what? What are these locations? 1, 3. Is it that simple? It is. So what did I do? I put it in like that. Oh, this is actually so much more simple than actually it is. If I just factor it out, x minus 3, and then that leaves me with what? E to the negative x, right? And then this equals to 0. If you factor this and tee this up and set x minus 3 equal to 0, you get 3, and then you get e to the negative x is equal to 0, but that will never equal 0 for any value of x. Therefore, we reject that part, and our answer is just x minus 3. But graphically, you guys saw it because that's exactly where it touched it. All right, cool. Let's put that back. Next question. All right, so here we're pretty much going to do the same exact thing, right? What I'm going to do is bring decimals back out. Is I'm going to factor it, so I'm going to say that it's going to be 2x squared minus 72x And then in parentheses, they both have e to the negative x is equal to 0. Well, since that can't ever be equal to 0, then I would have 2x, and I'd be left with x minus 36, right? So then my answer is 0 and positive 36. So my answer is 0, comma, positive 36. Factor the left side, factor the right side. Did I do something? 72 divided by 3. I'm sorry, 72 divided by 2. Divided by 2. 72 divided by 2, that's right. 2x. T is equal to 0. 0, comma, 36. Using 72 divided by 2, right? It's 36. X. Oh. 2x squared. Oh, there was no x to it. Dang it. My bad. So this was x squared minus 32, x squared minus 72. So then that's going to be 6 and negative 6. Oops. 6 comma negative 6. There we go. Okay, so now here I'm going to add e, so that becomes e to the 4x plus 6 is equal to e to the 1. 1 minus 6 is negative 5. Negative 5 divided by 4 is negative 5 over 4. I don't think it could be, we're good. Okay, graph this function. Literally just take this into Desmos, guys. We're not here to play games. We're here to get answers right. So let's do this. We're going to type this as x parentheses 2 raised to the x, 2 raised to the x, and then close those parentheses, and let's see what this guy looks like. Go back to the home page. It dips down a little bit, then goes back up. It dips down a little bit, then goes back up. I didn't look at the scale. How close does it get to negative 1? Like halfway? There we go. Graph this, go right into Desmos, and this is going to be y is equal to fraction. Numerator is going to be 300 over 1 plus e shift 6 to the negative t. And I can't do t, I got to do x, so that this will graph. And then between 0 and 6, home page. So this is an exponential growth. There it is. So is it something like, what's the difference? The number that it levels off on? Who can tell? I have no idea what the difference between these two are. They both go to the same exact. They go to one box away. Whatever. I got lucky there. Okay. So now here I need my equation. My equation for this is going to be a equals PERT, and then we literally just go right into Desmos, guys. Desmos, we go right here, and I would do principal 10, 1, 2, 3 times e raised to the RT 0.0315 times 12 years gives me that number. I can literally copy paste it and then just paste it in there, rounding to the nearest cent. That probably gets rounded up. I think it gets, was it a 6? Oh, I don't remember what the number was. It was 6.5, so that goes up to a 7. No, the value of the investment of $10,000. Oh, I put too many zeros. Where's Desmos? I put 10,000 times. Oh, that's why. This is, I gotta put parentheses around this because it's not taking it, times the 12 years. Copy, delete this, paste, and then that's just gonna go to 63. There you go, $14,593.63. Awesome. So here, suppose that a 14 is invested at that compared. Okay, so let's do this. Go back to Desmos. So here's my calculator. I'm investing 4,700 at a 3.8%, 3.8, so 0.38%, and now it's compounded monthly. So what I would do here is I would change this into 11 divided by 12. So after your 11 months, it would be worth this. I'm just going to go like this. Oh, nope. I gotta control copy, control V, 0. Wait, what? Be sure that the variable t for time is expressed in years. Yeah, 11 months. Alright, Desmos, what did we do wrong? 0.038 times 11 months out of 12. Oh, this is compounded monthly. This is the continuous formula. I need a different formula. Cancel. The formula is p plus 1. I need this. Okay. Desmos. It's a different formula. The formula is my principal, which, so I'm just going to write this p1 plus fraction rate divided by m, close that, raise that to the m times mt, right? So now check out what's cool about Desmos is if I close out of this, bring back Desmos, I now have sliders. So if I were to change my principal to 4700, my rate to 0.038, my months to 11, no, it's core compounded monthly. My time is 11 out of 12. Which would then give me this. Dang. Copy. And then, so that was 4866. 486633. I was off a little bit. Yep, see, a few cents and I was off. Alright, now for 11 years. And now what's cool about Desmos is I could literally just change this from 11 out of 12 to 7 years. And now it's worth that. Control copy, control V. And let's just go backwards. Let's make that an 8 and check answer. Beautiful. Oh, okay. So a couple just had a baby. How much should they invest now at 5% compound daily in order to have 40,000 in the child's education account? So if I look at this, if I look at Desmos, I can make this equal to y equals. Okay? Now, daily means that it's going to be 365 day a year, they tell us right there. Good. Okay. T is going to be X. And my principal, oh no, I'm sorry, T is 17 years. My principal is X. How much should we invest? 0.38, 5.8. 5.8. So principal, I don't know. This I don't know. This I don't know. This I don't know. This I don't know. And I want to know when this is going to be equal to 40. 1, 2, 3. So now if I zoom out, Something here isn't right because it makes no sense. X is my principal. No, wait. The couple should invest 14,000. Oh my god, this was that easy. So what was it? What'd I get? Where'd it go? 14,923. $14,923. And how many cents? And 81 cents. 0.81. Guys, if that worked, that's really cool. So here we have 1492381. I literally just wrote the equation for compounded daily. Oof, I was close. What if I do 80? No, a couple should invest 14,920. Or round to the nearest dollar. 4. Wow, that's really cool. Okay. All right, find the value of $25,000 at the end of 1 year if it's invested in an account that earns an interest rate. Boom, and it's compounded monthly, daily, quarterly. So now I'm going to go back to Desmos, and because I did all this work, it's all there for me. So let's go ahead and just adjust this all real quick. I don't need the 40,000. My principal interest rate is going to be 25,000. I'm going to be investing it at a rate of 6.3%. And right now I'm going to be this is a monthly is 12. And how long was my T? What is the value of the money's? Oh, 1 year. T is 1. No problem. So what would it be worth? It'd be worth this. Do not round to the final answer, then round to the nearest cent. What if it was daily? Daily, I'm going to change this to 365, and now it's that. And 3. Guys, trust me when I say Desmos is like your absolute best friend. It's graphing calculator for computers. Cool. And what's the value of the money if it's quarterly? That would be 4. 4. And it would be that. Control copy, Control V. Let's backspace a little bit of this, and that stays exactly there. Cool. Done. A company is trying to introduce a new product to as many people as possible through the television advertising area with 2 million people. A model is shown there, and it's found that that graphs about what value of n tends to as it increases without bound. Oh, first graph the function. So let's just graph it. Desmos. I'm going to duplicate this. I'm going to save that just in case the next question asks me to do anything. So let's do this. We have y equals 2 parentheses 1 minus e raised to the negative 0.044t. And then if I close that and we zoom out, there's our graph. So it looks like it's approaching what? Was that 1.9? So it looks like it's approaching. I don't know the difference between these. That one looks like 2. Is that it? What value of 2? You guys want to see how math can sometimes make sense? A company is trying to introduce a new product to as many people as possible through television advertising in a large metropolitan area that has 2 million possible viewers. So how many, as like my product gets out there and more people buy it, what's my maximum number of people that can buy this? 2 million. That's how many people are viewing the commercial or whatever. All right. Oh, regression. Okay, so let's go copy to clipboard, and let's just copy this, open this up in Desmos, and I'm just going to delete that. Please paste nicely. Boom. What is this? This is going to be an exponential regression. Now I can bring this up here. It looks like an exponential regression, right? There's my equation. Let's put this over there. Oh, let's put this here. Let's bring that over there. I can close this. So what is my equation? My equation is going to be 2.7. 1, 2, 3, 4. Let's just write it. 2.7 7905 times, wait, what? This is a terrible number. This is 0. 4 decimal places is like 0. 1.1758. Oh, they did it to me again. Since 1994. Dang it, they always get me. So that means that this is going to be year 0. This is year 3. Oops, what did I do? So this is year 0. This is year 3. This is year 6. This is year 9. This is year 12. This is year 15, right? And then now, if we look at this, close that, this gives me new numbers of 83.3155, and this number is 1.1723. Dang! What did I miss? What did I miss? What did I miss? What did I miss? Exponential regression 0, 3 years later is 97. 3 years later is 2000. 3 years later is 2003. 3 years later is that. 3 years later is that. 1. Could that round up to a 6? I swear to God, if that rounds up to a 5, 6. 83.3. No, I was way off. What? Where did these numbers come from? 15.17. Dang it. Let's just do it again. I missed the whole line and my graph was off. I'll get this in the first attempt. Okay. Copy to clipboard. Control copy. Control paste. This is going to be year 0. This is year 3. This is year 6. This is 9. This is 12. This is 15. And then this is year 18. Done. Here, linear, exponential, 41.86 for 8642 and 1.1902. I got it wrong on the first attempt. 2.4. 3 years later, 15 years. 18931.1. Where am I wrong? Why does this equation not look anything good? It doesn't look anything like a good graph. Why is it not? Why is it not? Why is it? A, B to the X. Four one 8642111902 raised to the X. My graph doesn't look good though. I'm really off. Why is that? Hmm. I'm like nowhere near this. Let me pause this for a second. Alright guys, what I did was I took the correct answer and I plugged it into here. Oh, 1.3. And I can't get my line to be closer. I've done everything. I'm not 100% sure what I'm missing. But as you can see, my lines are a little off. Therefore, my answers are a little off. And the purple line is not a good estimator. I don't know. I don't know what I'm missing here. But then once you just plug this in, I could plug it in. So like for example, if I just get rid of this, and then what year would it be? 2024 would be 12 years from there, so that would be the 30th year. And then if I plug in 80659 million 60, gotta round up. There you go. So that one I got. That's I don't know. I don't know. I don't know. Okay. I'm not sure. All right, let's take a look at this question. All right, marine life is dependent upon the microscopic plant life that exists in the phonic zone and goes to depth of 1% per that. In some waters, there's a great percent there, 20%, 15%. This is given by the equation of there where I is the intensity of light. What percentage of surface of light will be at the depth? So let's pull up Desmos, and let me just write this, and let me do another new Desmos. Let's do, in some waters, where IO is the intensity is given by, is that a 1? So is it just 1 divided by e raised to the negative 0.31 and then was that times 5 times 5? Intensity of the light at the surface. What percentage of surface light will reach the depth? Round to the nearest percent. Can I say 5%? Is that going to work? I just need to see if I'm using the right equation. Let's give you an example. Oh, I gotcha. See, okay, that was so much easier than what we were trying to do. So all I have to do is just to take this number and do that. So 21%. And then now at 10 feet, I would go in back to here, and then instead of 5, it'd be 10. And what percent of surface light? That would be, the nearest percent would be 4.5, so that'd be 5%, I think. There you go. And that is the homework assignment done. So the only one that gave me problem is doing the regression, which, interesting. Okay. Best of luck, guys. 43 minutes.